variable stresses, Goodman and Soderberg equation. We'll solve the problem. A machine component is subjected to fluctual stress which fluctuates between 300 meganewton per meter square and minus 150 meganewton per meter square. And this is a sigma max, that is its fluctuating stress. Maximum value is 300, so it is a maximum stress sigma max 300, and minus 150 is a minimum stress sigma minimum 150 meganewton per meter square. Okay, so sigma m equal to sigma max plus sigma max plus sigma minimum by 2. Okay, 300 minus 150 by 2. Okay, 300 minus 150 by 2, so it is 75. And sigma v 300 sigma max minus sigma minimum, so minus and minus become plus, so 300 plus 150 by 2. Okay, 450 by 2, which is 225. Sigma m and sigma v have been calculated. And Goodman equation, according to modified Goodman equation, you have to find the sigma u value, minimum ultimate strength sigma u. You have to find sigma u. A modified Goodman equation is 1 by n, that is 1 by factor of safety equal to sigma m. Sigma m is a mean stress, and sigma u is ultimate strength, plus sigma v is a variable stress, and sigma minus 1 is a endurance strength. This is according to Goodman equation. So in the Soderberg equation, 1 by factor of safety equal to sigma m by sigma y plus sigma v by sigma minus 1. Okay, sigma minus 1 or sigma e into stress concentration factor. Whereas in Goodman equation, 1 by factor of safety equal to sigma m by sigma u. Okay, instead of sigma y, it is sigma u. 1 by factor of safety equal to sigma m by sigma u plus sigma v by sigma minus 1 into surface finish factor, size factor, load factor, sigma v into kf. You have to multiply sigma v into kf, and all other factors you have to divide. Okay, so this is Goodman method. Okay, so in the Soderberg equation, it is you have to join sigma e, that is sigma minus 1 endurance limit strength, and sigma y, and in the Goodman equation you have to join sigma minus 1 and sigma u. Okay, so 1 by n sigma m by sigma u plus sigma v by sigma minus 1. So sigma m is 75, and sigma u you have to find the value, and factor of safety 2, factor of safety to be 2, and sigma v 225, and sigma minus 1 endurance limit strength. Endurance strength is, okay, yield strength is 0.55 into sigma u. Endurance strength is 0.50 of the ultimate strength. Okay, endurance strength is 0.50 of the ultimate strength. So sigma minus 1 is 0.5 of the ultimate strength. 0.5 into sigma u. From this you can calculate the values. It is 1 by 2 into sigma u, the 2 will go up, so it is 450 by sigma u. Okay, if you add, it is 75 plus 450 is 525. Okay, sigma u, you can add sigma u. If you take sigma u outside, 1 by sigma u outside, it is 75 plus 450 525. So sigma u equal to 525 into 2. Okay, 525 into 2, which is 1050 meganewton per meter square. Answer is C. Okay. So Soderberg line. Then next question, Soderberg line is used for brittle materials. Option A, brittle materials. Option B, ductile materials. Option C, elastic materials. Option D, both brittle and ductile materials. So Soderberg line is used for ductile materials, because Soderberg line joins sigma minus 1 and sigma y. Sigma y ultimate yield strength is used for always ductile materials, and sigma u ultimate strength is always used for brittle materials. Okay, like brittle material like glass and cast iron. Okay, ductile materials are aluminum, mild steel are ductile materials. So for this material you have to use Soderberg line, and for brittle materials you have to use sigma u. So here Soderberg line is used for ductile materials, because we are connecting it to sigma y. So answer is B, 36B. fatigue stress concentration factor Kf. Kf is endurance limit without stress concentration divided by endurance limit with stress concentration. Stress concentration factor is defined as the ratio of the maximum stress to endurance limit, nominal stress to endurance limit, maximum stress to nominal stress, maximum stress to maximum stress. So the option is C, not A, it is wrong. So option is C. So stress concentration factor Kt, okay, stress concentration. So when that area, in this area, that is the lines are not parallel, okay, and it is subjected to more stresses. So stress is more concentrated in the notch area, or it is a fillet area. In this fillet area, it is stress is more concentrated. So here the stress concentration factor Kt equal to maximum stress divided by nominal stress. Nominal stress at all other areas. Okay, maximum stress in the changes in cross sectional areas, maximum stress we can obtain. So stress concentration factor equal to maximum stress by nominal stress. So stress concentration factor is defined as maximum stress to nominal stress. So option is C, it is not A. Preferred numbers are arranged in geometric series. Preferred numbers. So in preferred numbers are R10, R20, R5 and R40 are the preferred numbers. The preferred numbers, so they are arranged in geometric series. Okay, they are arranged in geometry, they are derived from geometric series. So they are the powers of 10 to the base is 10 and it's the fifth power, and one is multiplied with the other, and we are getting the series of numbers. They are called preferred numbers. R10 series, R20 series are the preferred number series. Okay, R5, R10, R20 and R40 are the preferred numbers. In the R5 series, first number is 10 to the root of 5, and next number is multiplied with the same number, and the next number with that previous number. Similarly, they are arranged in geometric series. Okay, in data book you can see in page number 7.19 and 7.20. So preferred numbers are arranged in geometric series. Next question, the ratio of ultimate stress to the design stress is known as factor of safety. Stress to design stress, ultimate stress to design stress is called as a factor of safety. Ultimate stress or the yield strength by design stress is also factor of safety, or ultimate strength by factor of design stress is also called as factor of safety. Answer is C. When a material is subjected to fatigue loading, the ratio of endurance limit to the ultimate tensile strength is 0.5 into sigma u. Endurance limit is sigma minus 1 equal to 0.5 into sigma u. So the ratio of sigma u by sigma minus 1 by sigma u is asked in this problem. So it is 0.5. So answer is C. The ratio of endurance limit in shear is shear to the endurance limit in flexure is 0.55. Okay, ratio of endurance limit in shear to the endurance limit in flexure. Okay, that is sigma tau minus 1 equal to 0.55 into tau. Okay, 0.55 into tau. Okay, so it is 0.5. Answer is C. The surface finish factor for a mirror polished material is 1. Okay, you have to, in the Soderberg equation, 1 by factor of safety equal to sigma m by sigma y plus sigma v by sigma minus 1, and you have to multiply surface finish factor and size factor, and you have to multiply load factor, and you have to divide surface finish factor, stress concentration factor at the numerator. So for this surface finish factor, this value is equal to 1. Stress concentration factor is defined as a ratio of maximum stress to the normal stress. Answer is C, maximum stress to the normal stress. In static loading, stress concentration is more serious in, that is option is brittle materials. In cyclic loading, stress concentration is more serious in ductile materials. In cyclic loading, stress concentration is more serious in ductile materials, whereas in static loading, okay, under normal loading, tensile, compressive, shear, they are called static loading. Under static loading, stress concentration is more serious in brittle materials, whereas in cyclic loading, stress concentration is more serious for the ductile materials. Okay, here the option is A. For static loading, it is option is A. The ratio of ultimate stress to shear stress is known as, okay, Ultimate stress to shear stress is known as factor of safety. Option is C. Notch sensitivity factor. So it is given by the symbol Q. Okay. Q equal to, that is Kf equal to fatigue stress concentration factor. Kf equal to 1 plus Q into Kt minus 1. Kt equal to stress concentration factor, theoretical stress concentration factor. It is equal to maximum stress by nominal stress. Okay, Kt equal to maximum stress by nominal stress. Kf equal to endurance limit without stress concentration divided by endurance limit with stress concentration. Okay, Kf. Kf equal to 1 plus Q into Kt minus 1. So Q equal to Kf minus 1 divided by Kt minus 1. Okay, Q equal to Kf minus 1 divided by Kf minus 1 divided by Kt minus 1. So option is B. Notch sensitivity factor Q is defined as Kf minus 1 divided by Kt minus 1. Okay, in cyclic loading, stress concentration is more serious in that is cyclic loading, it is more serious in ductile materials. Okay, cyclic loading, option is D. Cyclic loading stress concentration is more serious in ductile material. Option is D. A basic shaft is one whose upper deviation is 0. Basic shaft size is 1 whose upper deviation is 0. A basic hole is 1 whose lower deviation is 0. Okay. The fit on a whole shaft system is specified as H7S6. The type of fit is force fit or interference fit. Always H7 and S6 or F6 or J6 all are force fit or press fit or interference fit. So option is D. Thank you.